Hello class, today we shall be learning about chemical reactions. Now, the 5 chemical reactions we have here are synthesis, decomposition, combustion, single displacement, and double displacement. Alright. So first up, we got synthesis. So Spartanose version, it's basically A plus B equals AB, which is basically two elements, or two compounds, mixing together to form a singular compound. For example, we have CO2 and H2O, which then turn into H2CO3. God damn. Alright, so we already went over what synthesis is. So I hope you all marked it, but just in case. Now that we got this done, on to decomp. So over here we have decomposition, which is the opposite of synthesis. So basically, it is AB turning into A plus B, or the compound turning back into its elements and or compounds. So we're going to use what we got for synthesis for this one. So we get H2CO3 aqueous, and it'll turn back into CO2 gas plus H2O liquid. And that, my friends, is decomp. So, now that you've seen decomp, I hope that you have already placed your line where it's supposed to be, but if you haven't, voila. Alright, now that we got this out of the way, we're moving on to our final topic, combustion. Alright, so onto the next topic, combustion. So for combustion, we basically have a molecular compound with carbon and O2, which is oxygen, to give us CO2 and H2O gas. Keep in mind, if you're heating it up, by the way, this little triangle over here, this means heat. If you're heating it up, not like most of the time, well, not even most of the time, yeah, say most of the time, it's going to be gas, because, well, it wouldn't make sense for it to be liquid if you're heating it up, right? Now, for this, I chose methane, CH4. However, I'm pretty sure most of you can tell what's wrong. I'll give you a minute to think about it. Alright, that's enough time. So basically, this equation is not balanced. What we need to do is balance it. So, let's get to it. Alright, so as you can see, this equation is not balanced. We have one C and one C over here, which is carbon. It's fine. But once we get to the H and the O, we can see there's a big difference. There's 2 H's over here, well, there's 4 over here, and there's 2 over here and 3 over here. We can't leave like that. So let's balance the equation. We get 2 over here, which means this goes from being 2 H's to being 4. And over here, we have 2 O's because of this 2. We have 2 O's over here, 2 O's over here. That means we have 4 over here. And this makes our job easier because all we have to do is then write a little 2 over here. This then switches over to be a 4. And your equation is now balanced.
Okay.
All right, so to finish this off, we already went over combustion. And what is the formula here for combustion? You're all smart, you got this. That's right.
Now that we have reviewed so far 3 types of chemical reactions, which one out of the 2 options that we have left you think it's a single displacement? So come with me, I'll show you. So basically a single displacement is A plus BC arrow that indicates that a chemical reaction happened, AC plus B. So on this side we're going to have the reactants, and then we have the arrow that indicates that a chemical reaction has occurred. So then, magnesium is by itself, so that means that it has a neutral charge. And then on the other hand, we have hydrogen. So here on the periodic table, we have that hydrogen is +1. It's on the left side of the periodic table, so that means that it's positive. And then we have chlorine that is on the right side of the periodic table, which is the negative side, so it's going to be negative. So it's going to be +1 and -1. And we know that H is going to be +1, and chlorine is going to be -1. And magnesium does not have a charge. On this reaction, what basically is going to happen is that magnesium is going to go with the chlorine. So it's going to be MgCl2. And now magnesium passes from not having a charge to actually have a charge. And now what is going to happen with the hydrogen? So the hydrogen is going to come out to this side, and since hydrogen is a diatomic molecule, it must have a 2 over here. But actually now it's the hydrogen, the one that does not have a charge. It used to have a charge over here when it was combined with chlorine, but now over here it doesn't have a charge because it's by itself. So what we can observe from here is that two things are happening: oxidation and reduction. Basically, an oxidation means loss of electrons. It's when it passes from not having a charge to actually have a charge. And reduction is when it used to have a charge and now it doesn't. So it has been reduced. Now that we know what a single displacement reaction is, now we can confirm that a single displacement goes with this one over here. So now the only one that is missing is double displacement. Now, in the case that A is positive, B is negative, C is positive, D is negative, so that's going to explain the arrangement that we have over here. Because the positive is going to go with the negative, so that's why AD is here together. And then CB, positive, negative, is going to come over here. Now, let's suppose that we are going to combine these two. So we know that sodium has a positive 1 charge, and that carbonate has a negative 2 charge. So if we're about to combine it, we know that we have to cross the charges, so it's going to be Na, and this 2 is going to come over here, and the CO3, which is going to stay like that because we have a 1 over here. So after getting this, we know that sodium makes any solution of aqueous. And now we're going to combine it with calcium chloride. Calcium is on the left side of the periodic table, so it's going to be positive 2. Positive 1, positive 2. And then for chlorine, it's going to be on the right side of the periodic table, so that means that it's going to be negative, and it's going to be negative 1. It's over here. So if we're about to combine this, we're going to have Ca with a positive, with a 1 charge, but we don't put it, and then we're going to have Cl, but with this 2 over here. And it's going to be aqueous since this is not an exception. So we know that if we combine these two, though, we know that the sodium is going to go with the chlorine. So it's going to be NaCl aqueous. They're both 1, so no numbers are going to be here. Then plus, we have CO3 that has a 2, and then we have Ca that has a 2. So we're not going to have numbers over there either because they're both 2. So it's going to be CaCO3. And then we're going to have CaCO3. The charges, they're going to be canceling out. And this is a solid because it's actually an exception. Just to add to this chemical reaction is that when two aqueous solutions are combined, a solid is formed. And this is also called, this is like a subcategory to the double displacement reaction or single displacement reaction, and it's the precipitation, it's the creation of a solid. So remember that aqueous plus aqueous will create or will permeate a solid. And that this type of reactions, they're called precipitations, reactions. Have you ever wondered why when you're eating an apple and you just stop eating it for a couple of minutes, that apple turns out to be this color right after? It passes from being white to be browned. There is actually a chemical reaction happening in there. And what's the type of chemical reaction happening?
Another sign of a chemical reaction is the formation of a solid. So as an example, I made Italian herb bread. First thing I did was add a cup and 2 tablespoons of water to a loaf pan. The next ingredient I added was 2 tablespoons of olive oil. Afterwards, I added 3 tablespoons of sugar, 1.5 teaspoons of herb salt, 2 tablespoons of dry milk, 3¼ cups of bread flour. It's a lot of flour. 3 tablespoons of Italian seasoning, and 1.5 teaspoons of active dry yeast. So, when we combine all of these ingredients, the gluten, which is the protein in the flour, binds together to create the dough, and when the dough is left to sit, it rises due to the yeast releasing gas, which is another sign of chemical reaction. So you'll see here, this is the bread once it's risen. When the dough is baked, we're left with a yummy and very sturdy loaf of bread.
I know that when you observe this, you believe a chemical reaction is taking place. Well, you're right. Right now, a combustion reaction is taking place right here. A combustion reactions involve a fuel that reacts rapidly with oxygen to create light and heat, with the release of oxygen, of water and carbon dioxide. Combustion reactions are exothermic, which means they release energy in the form of heat. In this example right here, when you light the candle, the heat will melt the wax, and then the flame's heat will vaporize the liquid wax and undergo a combustion with the presence of oxygen from the air. This combustion reaction will produce carbon dioxide, water, light, and heat.
Lastly, you can tell a chemical reaction has taken place when a gas is formed. For example, when you add baking soda to vinegar.